Welcome to the deep dive. We're here to crack open complex new research, give you that knowledge shortcut you need. Today, we're tearing into construction, one of the world's oldest, biggest industries. And anyone who's, driven past a big construction site, they know what it often looks like. Chaos, right? You see those mountains of rebar just sitting there, pallets of bricks in the rain, maybe crews just standing around.
Yeah, waiting for that one part that didn't arrive on time.
Exactly. And that inefficiency, that waste that seems kind of built into traditional construction planning, it's just staggering when you're relying on the old ways, the manual forecasting. Well, often it's based on project schedules from years ago, or sometimes, honestly, just guesswork. The results, huge cost overruns, so much wasted material, and schedules just slipping and slipping. Our research really highlights this.
And that's precisely our mission today in this deep dive. We're looking at how AI, artificial intelligence, isn't just a small improvement here. It's fundamentally changing how decisions get made in construction. We're moving away from that expensive guesswork and more towards precise data-driven forecasting. Think of this as your fast track, really. Understanding how this massive global industry is being pushed towards being more sustainable, more predictable, and, yeah, definitely more profitable.
Okay.
The core finding we're digging into today is this promise. Smarter decisions from day one, from the blueprint stage even, leading directly to, well, drastically less waste and much better project efficiency overall.
That sounds like the dream for any project manager, doesn't it? But let's be real, AI is a huge buzzword. How exactly does it manage this accurate forecasting? Predicting the future on a construction site seems, well, almost impossible.
It does seem like it. And it's not magic, but it is incredibly sophisticated machine learning. See, unlike the old methods that relied on maybe static historical averages from similar-ish projects.
Right, like the last office building used X amount of concrete.
Exactly. This new approach uses specialized algorithms, often things like neural networks, doing what's called multivariate risk modeling. It's complex stuff. And to do this, the AI needs feeding. It basically runs on three key things. First, huge amounts of past project data. This is like the company's memory, what really happened on old builds, not just what was planned on paper.
Okay.
Second, it pulls in real-time external data. Think specific environmental conditions, detailed local weather forecasts.
Stuff that changes constantly.
Constantly. And third, it factors in current market trends, analyzing everything from, say, global supply chain hiccups to local material prices and even labor availability.
Okay, hold on. That first one, past project data, I want to dig into that. In the past, you might look at total concrete use for a similar building, like we said. But what detail is the AI actually looking at? Is it just the final numbers?
Oh, it's way, way more granular. It's not just the final count. It's analyzing why things deviated. So, for instance, maybe on Project A, they ended up using 15% more rebar than planned. Why? The AI learns it was because of unexpected soil conditions needing deeper foundations. It learns not just the budget outcome, but the reason the budget worked or failed across thousands of tiny tasks.
Wow. Okay, so the synthesis here is what's fascinating. I can picture a human planner trying to juggle those variables, past cost overruns, a surprise week of rain, maybe a sudden steel tariff.
Right.
But a person can really only handle those one by one or maybe focus on just the biggest problem.
Exactly right. The AI connects all these diverse, often seemingly unrelated data points, and it does it simultaneously and constantly. Think of it like a super advanced GPS for your entire project budget.
Okay.
It doesn't just find the shortest route. It finds the cheapest, factoring in current material costs, real-time delivery traffic, potential weather delays all at once. And that ability lets it predict pretty much the exact quantity of materials and the labor hours needed, factoring in probabilities for risks, minimizing that complex guesswork. That's the real game changer in the planning phase. Makes it so much more solid.
That makes a lot of sense for materials. Physical things, you can count them. But here's where it feels even more complex. AI isn't just counting bricks. It's got to optimize the human element labor. That's always the biggest variable, isn't it?
Always.
So let's really look at this dual forecasting system. Materials and labor. Starting with materials, the immediate win our source talks about is preventing both too much and too little.
Right.
We get why preventing shortages is key, keeps things moving. But the excess, let's talk about that for a second. If you overorder steel by, say, 10%, that's not just the cost of the steel itself.
No, not at all.
Storage costs, right? Security, maybe. And then disposal costs if it sits too long and degrades or just isn't needed.
And those costs add up incredibly fast. Especially think about dense urban projects where every square foot of space costs a fortune.
Yeah.
Accurate predictions slash those costs straight away. It lets you move towards more of a just-in-time inventory model. The system knows, based on progress and maybe that weather delay, exactly when the crane will need the next 50 beams. So it ensures only those 50 beams arrive, say, an hour before they're actually needed, not weeks in advance.
So it's like inventory management, but supercharged by predictability. Okay. But now the really tricky part, labor forecasting. What specific things does the AI look at to figure out crew needs? Because people are complicated.
They are. And this is where the machine learning gets really powerful, but also needs careful handling. It goes way beyond just guessing, we need 3 carpentry crews. The AI models look at several detailed factors, things like the specific skill sets needed for the next tasks coming up. It analyzes historical crew performance.
You mean like Crew B usually finishes framing 12% faster than Crew A. That specific.
Exactly that specific. And it looks at detailed past work schedules, noticing patterns like maybe productivity dips on Friday afternoons or boosts after a certain milestone is hit.
Okay, that sounds amazing, but I have to play the skeptic here. Doesn't tracking crew performance like that raise huge challenges?
Yeah.
How does the AI know if a delay was genuinely poor performance or if it was because, say, the materials didn't show up on time? That seems critical.
That is the critical question. And it really comes down to the quality of the data feeding the system, the pipeline. Because the AI is integrating all the data streams, material deliveries, weather, equipment status, and crew task logs, it can actually start to untangle those causes.
Ah.
It learns that maybe Crew B was slow last Tuesday, but it wasn't inefficiency. It correlates it with the crane being down for 3 hours that morning.
Got it.
This kind of precision means that when the AI forecasts crew needs for the next phase, the prediction is based on, well, genuine attributable performance, not just skewed averages.
And the payoff for getting both materials and labor right,
Yeah.
that must be massive for the budget.
Oh, absolutely. AI's precision here prevents the 2 big budget killers, overstaffing and understaffing.
Right.
Overstaffing is just pure wasted money. Every day you have extra people on site unnecessarily, profit shrinks. But understaffing, that can be even worse. It causes those catastrophic delays that ripple through the whole schedule.
Penalties, extended overheads.
Exactly. Preventing both means better labor cost efficiency, obviously, but crucially, it helps keep those overall project timelines from blowing out.
So when we boil it all down, the core advantage that our sources keep coming back to is minimizing waste. Simple as that.
It is.
And yet that hits the bottom line, which every CFO loves.
Yeah.
It's also a really significant step towards more sustainable construction. Actually sustainable. I think maybe the biggest shift is moving away from needing that safety cushion, you know?
Contingency.
Yeah, traditional planning meant ordering 15% extra just in case, which automatically builds in potential waste. The AI seems to replace the need for that cushion with a need for data accuracy instead.
That's a great way to put it.
Yeah.
And if you connect that to the bigger picture, it's really a systemic shift.
Yeah.
AI isn't just a little tweak to shave a few points off cost overruns. It's fundamentally changing the whole resource consumption model for construction
How so?
by making sure only what's needed is ordered, delivered, installed.
Yeah.
We move away from this inherently wasteful default setting the industry has had for decades
Right.
towards a model driven purely by precision and data. And that focus on efficiency, that's what fuels real innovation. Good for the planet, good for the shareholders.
And it must create a competitive edge too, right?
Definitely. Companies using this precision can bid more competitively, deliver more reliably. They'll start carving out market share from firms stuck in the old ways, relying on those bloated contingency plans.
Which leads us nicely into the practical side. The tools. This isn't just theory anymore. The source material we looked at points to specific AI-powered tools being integrated now into construction planning systems. These are the actual engines doing the work.
Yeah, this is where the rubber meets the road.
So let's list them. We've got predictive analytics platforms, often cloud-based, right?
Yeah.
Doing that super accurate material forecasting, crunching historical costs, supply chain info.
That's one category.
And then you have AI-driven scheduling software that's managing the labor optimization piece, the timelines, coordinating different teams. But tell me, how are these fundamentally different from the sophisticated project management software people have used for years, like Primavera or MS Project?
The key difference is dynamism.
Yeah.
Traditional software, it's powerful, but it relies on you setting up the initial plan, the dependencies, like a detailed Gantt chart.
Right, you build the model.
You build the model. And if something changes, say the concrete pour is delayed, you, the human, have to manually go in and shift everything that depends on it downstream. These new AI tools, they're constantly pulling in real-time data from multiple sources to automatically adjust those relationships and predict the knock-on effects. So, for example, the software isn't just getting data from the project site itself, like Foundation Board. It's connected to external APIs. It sees the updated 6-week weather forecast. It sees a notification from a supply chain tracker about a highway closure impacting your drywall delivery.
Wow.
Or maybe it gets an alert from a local union about a temporary labor shortage in a specific trade.
So if the forecast suddenly calls for heavy snow next week, the AI system doesn't just sit there waiting for a site manager to notice and react.
Exactly. It doesn't wait. It proactively models the impact. It calculates, okay, this likely means a 2-day delay for the exterior cladding work. It then instantly looks for opportunities. Can we reschedule the interior finishing crew to start early in another area? Might do that. And it sends an automated alert to the cladding supplier, adjusting the delivery schedule, all potentially before a human even reads the weather report. That's real-time insight.
That ability to proactively course correct instead of just reacting after the fact, that's huge. It must completely change the risk profile for these massive projects.
It really does. And this dynamic adjustment capability, it brings up an interesting point. What stands out most to you about the benefit of this dynamic planning? For me, it's not just the speed, although that's impressive. It's that the AI can analyze maybe thousands of possible mitigation scenarios in seconds. The time it takes a human planner to just manually adjust one task on the timeline, the AI has already found the optimal reschedule. It just presents the best solution.
That's a good point. I think for me, the most compelling thing is that it optimizes for multiple goals at once.
Okay.
Like traditional planning often forces a choice, optimize purely for speed or purely for minimizing costs.
Right, the classic trade-off.
Yeah. But this dynamic AI planning seems capable of optimizing for speed and cost and waste reduction simultaneously because it understands those complex interdependencies in real time. So wrapping this up, what does this all mean for the construction industry as a whole?
I think our conclusion is pretty clear and singular, really. AI-powered resource allocation. It's proving to be a genuine game changer. It's becoming the new standard for getting projects done reliably on time, on budget, and with less environmental damage.
And that word standard is key, the necessity of it. That's the main takeaway. Embracing AI in construction planning isn't some luxury add-on anymore, not just for the high-end developers. It's rapidly becoming a baseline requirement, a competitive necessity just to stay in the game. Especially in an industry that's getting more complex, where margins are often tight and there are always new regulations, new standards to meet. Absolutely. And that brings us to our final thought, something for you, the listener, to maybe mull over after this.
Yeah.
Given how much this AI relies on analyzing past data to predict the future, how does this technology evolve? How will it handle totally new, unprecedented projects?
Yeah, good question.
Things like, I don't know, building the first big underwater data center or the first large-scale carbon capture plant, projects where there is no relevant historical data or very little. How does the AI cope then?
That's a fascinating challenge for the future. And maybe more immediately relevant for people actually working in construction planning right now. What new skills do they need? When the job isn't just about using the AI's output, but about ensuring the quality, the integrity of that historical data going in. Because that reliance on clean, accurate past data, that's the absolute foundation. Managing that data, curating it, ensuring its quality, that might just be the next big hurdle in the next essential skill set.